Okay, I have top of the hour. Hello and welcome to our SIMUL8 online user forum. My name is Matthew Hobson-Rohrer and I'll be hosting today's session as well as presenting in the middle of this session. Let's start off with a few logistics about the meeting technology we're using. First of all, let's talk about the materials. So just to make it easy for you all, you don't need to try and take notes while you listen to our presenters and watch your screen. We will be providing the presentations and a recording of this session for folks to use later on. Also, if you can, just take a moment and look at your GoToMeeting window. You'll see on my screen here that with GoToMeeting it sometimes reduces the control panel to a small menu bar, and if you go to that menu bar and right-click on it where the orange arrow is, as you see on my screen, you can toggle the auto hide control panel off. That will leave that control panel up where you can ask questions and also type into the chat window. GoToMeeting has muted all the attendees for this session, and so your way to ask questions is to simply type them into the questions window. Please do that as those questions come to you, and that will give our presenters a chance to consider their answers and get to as many questions as we can through the course of this session. Let me tell you a little bit about myself. I've been in the simulation business for about half my life, so 25 years. I've spent most of that time focused on manufacturing, material handling, and scheduling applications for simulation. I have a background in engineering and business, and I am based in Salt Lake City, Utah. So by way of agenda, we're going to spend about 5 minutes here telling you a little bit more about upcoming events for SIMUL8 and also introducing the new features coming in our SIMUL8 2014 release. And then Jim Holtman from Kroger is going to take 15 minutes and present to us what they're doing at Kroger to help solve their process improvement challenges. And then I will present the power of SIMUL8 and talk about how companies, while they're improving their processes, have basically moved through the process in different ways, from potentially starting with a few simple problems to more complex problems, and how SIMUL8 helps support that. And then finally, Glenn Holburn from our support group will be spending about 15 minutes, and we'll walk through some of the powerful features in SIMUL8 2014. And at the end of each of these 15-minute sessions, we will answer some questions. So upcoming events, we have other online forums that we will be conducting. March 4th, we have a healthcare workshop. We also have from Brian Harrington, formerly with Ford, is going to present for us Breakdowns Happen, how to factor downtime into your models. And then on March 19th, we're going to be presenting the new features that are in SIMUL8 2014, and we are excited about that. Also coming up in April, in about the middle of April, we're going to conduct some training courses, likely both beginning and intermediate courses. And so if you'd like more information about that, please contact us. Finally, toward the end of May will be the Institute of Industrial Engineers annual conference. This year it's being held in Montreal. Should be an exciting location and venue, and we're looking to get together with our customers and users there as well to trade best practices and get feedback from you all. Let's also talk a little bit about what's coming up in SIMUL8 2014. I mentioned the webinar is going to be March 19th. The release date is March 17th for 2014. We've added some new visualization features. You can see the picture up there in the upper left-hand corner, a new way to visualize cues. We've updated our ribbon to show you, so the features stand out a bit more and they're more apparent to you. We've also added image sets for processes so that you can indicate process states based on different images, and you can tell from your model animation what's going on at your processes. We've also added scheduling features. You can see the picture on the right-hand side. You can now define a schedule for various resources and define how many resources are available at different times during your process. And we've done the same for arrivals travel times, and we've updated our visual logic interface as well with new folders and new commands. So we're real excited about these new features, and we hope that you'll join us on March 19th for the online review of these features, and toward the end of today's session, Glenn will be giving us a preview into those. So I'd like to introduce Jim Holtman. Jim has been 50 years in the IT industry, and 20 of those years in simulation. Jim is a Bell Labs fellow. There are about 140 of those folks in the world, so that's a very exciting distinction for him, obviously, and the recognition for his work at Bell Labs. His application areas have been in computer performance and large transaction systems. He comes from an electrical engineering background, New Mexico and Berkeley, and Jim is based in Cincinnati, Ohio. Interesting fact about Jim, Jim has his current position at Kroger because he helped other SIMUL8 users at Kroger through our online user forums. So it's a great example of how community can actually help you land a job that makes you happy and is exciting. So with that, Jim, I'm going to go ahead and change the presenter to you. If you'll go ahead and share your screen.
Okay, yeah. There's my cursor when you're ready. Okay, can you see my screen now?
Yes, we can. Thanks, Jim.
Okay. Good morning. I think as Matt says, I'm Jim Holtman. I work here at Kroger, the grocery store company. I've been with them about 6 years now in their operations research group. We have about 13 full-time staff here in the operations research group. My official title happens to be Data Munger Guru. I know how to process a lot of data and get statistics and stuff out of it. So what I'd like to do is at least give you a brief history or a brief overlook of what Kroger is. Kroger is actually the largest traditional grocery retailer in the U.S. We have over 340,000 associates, over 2,400 stores, fuel centers, convenience stores. We have the Fred Meyer jewelry stores. We're, have a lot of exposure in that area. Pharmacy, manufacturing plants. We've got like 34 distribution centers, and part of my job here for the last several years has been improving the operations in our distribution centers, and I've probably touched every one of those. So to give you a little bit of background about how we use SIMUL8 here at Kroger, I think as Matt said, I got my job because I was answering questions on the SIMUL8 Cafe, and one of the people that I was answering questions for was Doug Miser, who's my current manager. And he said, hey, the next time you're in Cincinnati, stop by and we'll buy you lunch. And I said, hey, I live here. I had thought I was only going to be doing some, 8 or 10 hours of consulting a week. But over the last many years, I've been full-time, and my only requirement is I'll keep working as long as it's fun, and it's been fun here, folks. There are several places within Kroger that we've been using SIMUL8. We've been using it since 2006. We've looked at what we call the front end of our system. The front end is the cashier, where you check out. And I'll actually go into more detail on the next slide on that. We've done simulation of several of our manufacturing plants. We've done a dairy plant to show when when and how we schedule the different types of milk being produced in it, and what kind of backlog we might get. We've also used it in simulating how we do some of our automated plants. We've done simulations of loading docks in the distribution center. When you bring pallets out from the warehouse and you have to load them onto trucks, there's limited space on the loading dock, and you have to get the loading trucks, putting those things on the trucks in a certain order. I've used it as a tool for training. I'll give you a couple simple examples because it turns out to be very easy to introduce queuing and what effects queuing has on performance and throughput of a system. The front end at a grocery store is one of the places where customers, experience either good things or bad things. They'll always make comments about, well, gee, how long did it take me to check out, and how long the lines were and things. And we've been doing a lot of modeling of the cashier lanes to understand how we can improve the efficiency there. And also, if you have been to a grocery store, you'll see that you've got regular lanes, you've got express lanes, you've got what we call self-checkout. And Kroger is introducing some new technology, and that's the reason we were using simulation of a technology called a scan tunnel. Brett Bonner, who's our Senior Director of R&D here at Kroger, had previously worked at FedEx, where he had been responsible for the installation, and you've all probably seen pictures of the conveyor belts with packages going down and being routed off in different places. He brought that technology to bear in how we can make checkouts faster. So now a customer basically can put an item on a belt. It goes through a scan tunnel which has multiple cameras that can find that barcode wherever it is and do the scanning automatically. And then out of the tunnel it goes right directly to a bagger. And this can make the front end much more efficient, and we had to understand what the impact of that was, and so we built a simulator for it. Now with that simulation we can vary the customer load, how big your basket is, how fast you're arriving, what type of payments, how many coupons. Those are the kinds of things that would go into a simulation and that you can vary. This is a screenshot of our front end simulator. You'll see over here on the left side are, for example, 6 self-checkout lanes. Now, depending upon what the configuration of the store, I may have 6, I may have 8, I may have 12 of these. Then I have the normal checkout lanes here, and I can have express lanes, I can have regular lanes, and what I'm not showing here that here's where we would put in one of those scan tunnels. Here it shows I've got like 1 express lane and 2 regular lanes open, and we've got visualization so you can see I've got a cashier, I've got people waiting in line, I've got baggers back here to bag, and we can vary all the different parameters to see what's going to happen. Now Kroger, probably like a lot of other grocery stores, has always had some type of policy as to how we make sure that the customer has a good experience. For a long time we had a policy called 1+2, that you would have 1 person being served by the cashier and at most 2 people in line. Now that was kind of hard to measure. You could do it with mystery shoppers and you could do it by observation. And one of the things we found out by running this simulation, that if we could open up registers in anticipation of what the load was going to be, we could reduce the customer wait time. And we ran this simulation. We also came up with some technology that we could buy that is basically a set of infrared sensors over each of the cashier lanes. And basically it can sense how many people or how many bodies are waiting in line. And as a result of running this simulation and finding this technology, One of the other things that we do with this technology is we put those sensors over the entrance to the grocery store, so I know how many people are coming in. I know, for example, that a normal shopping trip is probably somewhere between 40 and 45 minutes. So if I know how many people have entered my store, I know 45 minutes later probably what that load at my front end is going to be. And with this technology, we were able to put in place a policy now that Kroger has, which is called 1+1. One customer being served and one customer in line. And with this technology, we can now monitor that. And that all came about as a result of running a simulation with SIMUL8 and seeing what would happen if we could anticipate or be proactive. As a result of that, we have a system in place, and I think it's in all of our stores now, called Pew Vision. We have reduced the customer wait time to 30 seconds in these stores. I've given you a website where you can find out, again, what that technology looks like. And again, all this really came about because of running models and seeing what happens. If you go into a Kroger store these days, you may have noticed a monitor like this behind the cashier lanes. This is basically telling the store management, for example, this one says I should have 5 lanes open now. That's the one on the left. My action now is to have 4 lanes. I can actually close down a lane because we've looked at, what the anticipated arrival rate is, and we predict we only need 4 cashiers. And 30 minutes from now, I will need 4 cashiers. Now, one of the things that happens here is, yes, if I'm not using the cashier to be at the cash register, I can use them in other places in the store. But now the store management can be very proactive in how they staff. And as I said, this has reduced our wait times to 30 seconds. So the next time you're in our Kroger store, look for one of these. I've used it in a number of training courses that I've taught both here at Kroger and the other companies I have worked for. I have a course called Working the Numbers where I teach people the importance of having numbers and how they relate to both the performance of their system and any of the business processes. And queuing is one of the things that you want to teach people about. And being able to build simple models with SIMUL8 helps to illustrate this. One of the ones I've used is a simple model for a cashier lane. This is probably one of the first models that if you get SIMUL8 that you wind up building. It will probably take about 10 or 15 minutes with drag and drop to build this. And so you've got things, here's my input, how many customers are arriving, like one every 30 seconds. There's a queue here for the customers. There's a number of checkout lanes, and that's controlled by how many cashier resources I want to give them. I've got a processing time like 150 seconds on average to service a customer. You can change your different distributions, for, being an exponential, a normal, depending upon what your application looks like. So this was a simple model that you can put together and show them. You can make the model a little bit more complex. Here I just showed a larger part of the store operation. Here in the little red box is what I had on the previous one, and now this one shows that says, hey, I'm going to make 240 carts available to the store. Customers will come in. Hopefully there's a cart available. With the simulation says, hey, if somebody's had to wait more than 30 seconds for a cart, which says there wasn't one there, they may go shop someplace else. And so I can go and release the cart, and then every 30 minutes or an hour or however the schedule's set up, go and collect those carts out in the parking lot and bring them back. And again, these are things that help to model what the store operations are. So I would like to show another simple model, and as I said, let's go to the video, if I can find it here, hopefully. There it is. This is a simple model that I put together to show how an automated warehouse would work on the loading dock. And for example, I've got 8 trucks I want to load. In this matrix up here, here are the 8 trucks. And for simplicity, I've said each of those trucks can hold 5 pallets. And I want to load them on the truck in this order. For example, on truck 1, I want a red, green, green pallet. So I can set up this order, and in the model here, coming in from the left, I've gone and collected these pallets from the warehouse. And I'm going to collect, for example, all the red ones, all the green ones, all the blue ones. They'll come up to this first level of sortation slots here, and they'll be basically slotted in here. You know, for example, in zone 1 will be all the pallets that have to go in zone 1, which would be the A's over here, and then zone 2, zone 3, zone 4. So I'm going to drop off the pallets. When this zone 1 gets full, then it's going to be released so it can go down here and be sorted onto the trucks. So if I go here and run it, there we go. Okay. Okay. There we go. So you can see that the pallets have been coming in. Zone 1 was full, so now I'm releasing it to be run. And then zone 2 will be released, then zone 3, then zone 4, and zone 5. And then they're now being put onto the trucks in the appropriate order. So you can see there, truck 1 has a red, green, red, and it should have a green and a green. And so basically what this was doing was trying to illustrate to people how an automated loading dock would work. So that's kind of hopefully giving you an idea of how we have used simulation here at Kroger. And if there are any questions, I'd be glad to answer them.
All right. Thank you, Jim. It's great to see what's going on in a company like Kroger. And I certainly am going to take my stopwatch next time. I'm going to hold you to that 30 seconds for that queuing time. So
on average.
on average. Okay. Fair enough.
Don't go there at like 2 o'clock Saturday afternoon when every cash register is open because everybody's restocking their pantry.
Right. A quick question. How have you been able to get management support for simulation at Kroger?
Well, we were lucky there. As I said, Brett Bonner, when he came to Kroger, had used simulation before. And his philosophy is he wants to build a model before he builds the real thing. So it's been his practice to do that. In other companies, it's been a little bit harder, you know, if they haven't used it before. But in kind of my former positions, I could use it as a tool to show what would happen, and then we could actually go out and see what the real system did. And when you can show that, hey, my model did a real good job of predicting, people start believing.
That's great. And how did you, another question, how did you, can you give any examples then of how you kind of leveraged the power of SIMUL8 to do your job?
Well, one of the things I like about SIMUL8 is one, first, you know, it's got an ease of learning. You know, to do simple models, especially since it's drag and drop. I used to be a user of, GPSS, which was like coding in an assembly language. Much harder to build models. What I like about SIMUL8, one is it's easier to build the models, And then I make a lot of use out of being able to both import and export data and the use of VL, because a lot of my analysis is I use the SIMUL8 model to gather me the data, and then I've got some nice tools offline which can do a little bit more in-depth analysis and the graphics representation of what the results are.
Great, great. And just for those who may not be as familiar, VL is SIMUL8's visual logic interface. So, great. We don't have time for any more questions. We need to move along, but if a question comes to you, please do type it into the GoToMeeting window, and if we get time right at the end, we will address that question for you. All right, thanks, Jim. I'm going to change the presenter back to myself, talk a bit about the power of SIMUL8 and why it's important to those of you who are attending today and those who might listen to this recording later on. So if you've followed SIMUL8 for any length of time, you've probably seen that we really like to describe SIMUL8 as powerful, flexible, and fast. And I've drawn kind of a Venn diagram here to really illustrate that there is overlap between these three features. And what I'd like to do before we jump into this is I'd like to conduct a little poll of you guys to keep this interactive and to get some feedback from you. What we'd like to do is we'd like to know what you think describes a powerful simulation tool. So you can see here the poll on the screen. Please go ahead and respond to it as soon as you can so we can get some feedback about what you think power is all about. And that will actually help guide me a bit in my presentation and where I put emphasis. Okay, looks like the results are coming in, updating very quickly here, so I want to be sure I let it settle down a little bit. Right now it looks like 64% are saying ability to customize behavior, and the next in line is 48% integration with existing data. That's great feedback, and it looks like about 73% of the people have voted now. So I'm going to go ahead then and continue on to talk about the power of SIMUL8. So when we think about process improvement challenges within a company, and we need to, you saw the results of the poll there. Yeah, it looks like customizing behavior 70% in the end, and then integration with existing data 45%. So when we think about process improvement challenges, I've laid out here a quadrant description here. Lower left-hand corner, where you might start with a few simple challenges and going up the vertical axis to a few complex challenges. And then the horizontal axis is the frequency of those challenges, how often those challenges come up. And in the years that I've been in the simulation business, I've seen companies take a lot of different journeys, if you will, through this this matrix or this quadrant. This first journey I'm drawing here, a company might start with a few complex challenges, and then over time, as they adopt simulation and other technologies in their company, they may migrate to solving more problems, and they may become more efficient, solve more problems, and they might find some simpler problems to solve along that journey. Another way I see many companies start, small to medium-sized companies, is they'll start with a few very simple challenges, and they'll move to many complex challenges. So think of power, if you will, as it's kind of like, let's use a car analogy here. Power is when you step on the gas, that car goes. So think of that in terms of simulation and any other tools you might use in your process improvement work, anything that's in your toolkit. Power is what gets you going, gets you up to speed basically along that journey. So if I lay out in this quadrant system different technologies, different ideas, different tools, I've put spreadsheets down kind of toward the simpler end, because spreadsheets can solve a lot of simple problems, but when the problems have a lot of randomness in them, then it becomes more difficult for spreadsheets to represent that randomness that we see in actual systems. Likewise, on the upper left-hand corner, many companies, when they first start, rather than buying a simulation tool and dedicating people to using it, they might start with consulting, and they might have a competent simulation person actually come in and help them solve their more complex problems. Think of tool A and tool B here. It could be any other operations research kind of technologies that help you solve process improvement challenges. It could be linear programming, it could be other optimization tools, and so on. Where I put SIMUL8 in this whole quadrant, in these quadrants, is kind of smack dab in the middle. Because what I've seen with folks who use SIMUL8 is they're able to move from one area to another within this matrix, if you will, and they're able to use SIMUL8 from the beginning, when they start importing data from their spreadsheets, up until they're solving many complex problems. And I'll talk about why that is in the following slides here. Okay, so when you first get started, you can see the upper left-hand corner of this slide. You can see we're in kind of the left corner of the quadrants. If you have a few simple challenges, one of the first things you want to do is be able to import your data. And in our 2013 release, we introduced the Excel connections. It's a really quick and powerful way to get your data right from your spreadsheets into your models. And then we also have the objects themselves in SIMUL8 are quite powerful. For example, the picture on the right-hand side here shows all of the disciplines available for the routing in on an activity. And all that's available simply by double-clicking on the activity itself. Also, a queue you can define as having different disciplines: last in, first out, and so on. So starting at importing your data and using the powerful objects in SIMUL8, but also when you run scenarios with SIMUL8, you realize that every run that you make is really a data point, and so you need to be able to run scenarios with different random numbers, and SIMUL8 is set up. You simply click on the Run Trials button, and it will give you some confidence intervals around your key statistics and help you see how the randomness is really, the random behavior that you've modeled is affecting your overall operation. Some of the examples of people, customers, users who are just getting started, we're working with a company that produces electric vehicles, and they've been producing them for some time, but they really need to just take a step back and do some buffer analysis, and so they're using SIMUL8 to do that. Also, we work with several state agencies, and one in particular, a forensics lab. It's not a long and involved process, but there is quite a bit of variation in it, and they want to see how that variation affects the overall performance and how they can improve the performance of their lab. Now, if we go up the vertical axis here to the upper left-hand quadrant, this is where I would describe it as kind of casual use for a simulation tool if you should decide to purchase a tool and use it yourself. And when you're a casual user, as Jim mentioned earlier, you need a tool that's really easy to learn. It needs to be easy to learn, and then if you use the tool occasionally or casually, you want to be able to come back to it and model another process, 6 months from now, a year from now. SIMUL8 definitely qualifies there. We've spent a lot of time creating a tool that's easy to learn. The tool also needs to be powerful enough that you can create custom applications. We've demonstrated that. We have a tool called SIMUL8 Planner that you can use for doing scheduling. We also have Scenario Generator that's used extensively in the healthcare industry. So examples there of how the power of SIMUL8 helps you create custom tools where they might be occasionally used, but they can be rich in terms of the challenges that are solved. And then finally, consulting. That's always an option. At SIMUL8, we have a consulting team that can jump in, help you get a quick start to your first project, or help you meet a very tight deadline. And our users and customers who work with our consulting team find that they end up learning a lot about modeling and about simulation, as well as getting their project done on time. Some examples of custom applications that we've built recently. We've been working with a company that provides some technology for contact centers, and we've helped them build a tool for their sales team. We've also helped in the production of spirits and in the scheduling of that process as well. So as we move across the quadrants to the right-hand side, the increasing frequency of process improvement challenges that we have, this really means that you're going to do more simulation work, more modeling. What this sometimes requires is new users, but it can also require automation. Automation to help you be more efficient, to build your models more quickly, to leverage the computing technology to reduce the level of effort it takes for every model that you build. Of course, back to the easy to learn part, new users, it's easy to bring new users up to speed in Simulate and bring them on board. They could start with a free viewer license if you like, and then build from there to start creating their own models. And in terms of the features that really support increasing frequency, I mentioned the viewer. We also have a Simulate team offering where on a network license you can get a few folks using Simulate, collaborating, and that I've found in my experience that having people to bounce ideas off of really facilitates your learning and your ability to be successful with simulation. So team is a great offering. We also have had offerings in the cloud for nearly 5 years now, and the cloud is evolving. We're obviously hearing more about it out there in the technology businesses, and stay tuned. There's more work that we see will be done, we will do in terms of our cloud offering. And then finally, linking to databases and also an interface to XML, that allows you to build models outside of Simulate and then import them and run them. And that really feeds that whole idea of automating what you're doing to be more efficient and to be able to do more work in less time. Okay, finally, upper right-hand corner, large complex models. What we've seen, our users and our consulting team have built models with thousands of business rules and objects and work items. So there's really no limit to the size of a model that you can build and simulate. You can become much more efficient if you encapsulate and reuse some of the components that you create in Simulate. So we have features like sub-processes, components, and libraries where you can create your own objects so that you're able to build more complex models more quickly as you continue to grow using simulation as a tool. We've helped companies with very large contact centers, so we're talking about hundreds of thousands of calls coming in and thousands of agents, so very large models there, lots of data driving those models. We've also helped airports with their passenger flow, so thousands of passengers coming through security checkpoints and coming into the airport and helping make that more efficient as well. So just to summarize, I want to make sure I've conveyed the idea of what power is in simulation, and I didn't really touch as much on the customizing behavior, which was the winner in our poll, but Glenn's going to talk a bit about visual logic and how you can use it to customize the behavior in your model. I did talk about integration with existing data, our Excel user interface, and also our XML user interface. I think the thing to think about here is that we all, as process improvers, will have different tools in our toolkit, and simulation can be one of those tools, and the tools that we use should be complementary. For example, being able to import spreadsheets into your simulation tool. Simulate's also a tool that grows with you. You can start with your first models to do, let's say, some buffer analysis, and you can grow that to more complex systems and models over time and tackling more complex problems. Simulate does create real value, and no matter what your journey, that is really the goal. Is if you don't provide value within your organization, it can be a challenge to get support for doing simulation and using it as a tool. And I just want to reiterate that power is about boosting your speed and about creating flexibility. So power really is the guts of our powerful, flexible, fast messaging. So I have time for a few questions, and I will look to those questions, but I want to ask you, before we go to those questions, I would like to ask you all one more question, is where do you see yourselves in these 4 quadrants. So where in your process improvement journey as a company, where are you now? Okay, we have about 71% of the folks the voting. It looks like most people have a few complex challenges or a few complex simulations. Let's go ahead and show those results. About 50%, 25% there have many complex simulations. So we've really got to focus on the complex. I think that when you get to using simulation, you're often using it to solve those complex problems, so that does make sense. And only 10% have a few simple problems to solve. And a few of you still don't know. Hopefully you can think about that question some more, and feel free to contact us and let us know where you think you are, and ask us how we can help. All right, so back to my screen here. I would like to introduce now Glenn Holburn. Glenn is our head of our support group at SIMUL8. So his real goal is to make you guys successful, make our users successful. He's had experience in manufacturing and healthcare as well as contact centers, and his background is in information systems from Arizona State. So Glenn, I'm going to go ahead and change presenting to you at this point. And make sure that you
thank you very much, Matt.
All right,
I'm just going to go ahead and show my screen now. So yeah, again, thanks, Matt, for the introduction. Thank you, everyone, again, for joining us today. So as Matt had mentioned earlier, what I would like to do today is take a model here and show you guys some really powerful features that you can use within SIMUL8, and hopefully be able to apply them to your own complex problems and be able to solve them using some of these features. So I have a model in front of me here. It's a model of a car wash. So just to kind of go over a very high level, on the left-hand side is where our arrivals come in. Those will be our cars arriving into the car wash. They will go through this automated process, and that's on the conveyor of washing, rinsing, drying, and finally waxing. The cars will then go into a kind of hand detail station here, which is handled by one of the detail workers before the car actually exits the car wash. So in this model here, if I go to my start point and look at my actions, I am using a label to identify different types of cars, so perhaps of different sizes, or we have trucks versus cars. And if I look at the value of that, so I'm setting that between 1 and 3, so I have 3 different car types in this simulation, and they're arriving quite randomly. So if I quickly run the model, you'll see that the cars are arriving through, coming into the car wash, into the automated process here. But if you notice right there, you might notice the cars are going through these stages kind of at the same time, and that's not the actual behavior of what we want to see. I mean, we want to be able to limit this as only one car will be able to do this at a time. So we currently do have a problem there, but luckily for us, we do have a feature that will allow us to easily mitigate this. So what we're going to do now is show you guys how to create a group, and then we're able to set a limit of the number of work items that can be processed at any time within that group. This is a useful thing, because if you have a process that uses more than one activity or work center, but only a certain number of items can be present in the process at any time, then this is the feature that you can use. So I have already created a group in this simulation, but just to show you how to do that, I can select all of the activities and objects that I want to be in that group, which would be everything in this box. This is the automated conveyor. And I can right-click on my screen and use this Create Group option here. Additionally, I could also go to the Data and Rules tab. Some of you users might notice that there are the new icons, as Matt had mentioned, for 2014, so it has got a bit of a facelift. But we'll still find the Groups option here on the Data and Rules tab if we want to create a group that way. So if I quickly open this up, And we can see here, I've just called it Group 1, and it contains all of my conveyors and the activities in my car wash station here. So what I'm looking at here is the limit work items in groups. So if I reduce that down to 1, what that does is create that constraint that only one item can be present there at the same time, which will create that flow that we would expect to see at a car wash. You can also see in this group tab, I mean, you can get results specifically for the group, set its efficiency. So this is quite a handy dialog box that maybe some users are not yet familiar with. Additionally, we can also monitor the wait and the work time, for the group itself and compare that to the whole simulation's results. So we'll go ahead and do that as well and demonstrate how that's done. And once I do click the monitor wait and work time, I do have to check another option just to be sure I am recording those results. So if I go back to the Homes tab and go to the Results Manager, you'll see I have my results by work type or group. In this case, I'm looking at a group, and I want to analyze that during the run. So that will be available after I run this simulation. So now when I run the simulation, you'll notice that there will only be one car going through at a time. This is the intended behavior I want. So what I've done is, I've used that and created my own sort of behavior, in this case without the use of any sort of programming, visual logic, or any additional rules. It was simply an option in one of the features, that being the group feature. So hopefully you'll be able to utilize that in your own processes. If I just quickly speed up the simulation all the way to the end, and I can go back to my Home tab, look at my Results Manager, and we're able to review that information. So you will see I now have a small matrix. Of course, if I have multiple groups, those groups would show on here at all. But we can see the wait times and the work times. So I have my Group 1, that's everything inside of this box of my car wash, so excluding the detailing stations. And of course I have the numbers for the simulation as a whole. So this is really useful if there are specific areas of your process that you want to highlight, find results, and see how that's comparing to the rest of the simulation, especially if you're doing things like making changes. So that's available from you there from the Results Manager.
Glenn, before we jump to the next feature, that we do have a question from an attendee about how you show the capacity. What is the capacity for each conveyor? Can you just show that very quickly before you move on?
For the conveyors?
Yeah.
Sure, yeah. So I mean, if I click on a conveyor here, I get its properties. I'm able to set the length and the speed. So currently what's constraining the conveyor right now is my group. Obviously I can only have one item in this whole box at a time. However, I mean, with a conveyor you would be able to change its capacity by modifying the length and speed, and Simulate can then look at the size of the work item. You can, if you go to Advanced, you can look at your work item types and you're able to modify the size. My simulation's in meters right now, but you could change that to feet. And then that's another constraint. So you can change your size of your work items, and then by setting your length and speed of a conveyor, you're then able to control its capacity. So I hope that answers that question.
It does, thanks. And there's a follow-up question here. Can you replicate groups?
That is a good question. I mean, you can replicate things that are within a group. As far as I'm aware, within this group dialog, there's currently not an option to do that. But if that's something that users would find very, very useful, then I'd be happy to forward that to the relevant people and possibly as a kind of feature improvement.
Okay, great. I just wanted to get a few of those questions while they were coming in real time. Carry on. Okay.
Sure, not a problem. So I hope that answers the questions so far. And so we've just talked about using groups to limit it for this process here. So that's creating our behavior as normal. Now, if I look at these other activities here out with our group, detailing, I can look at the timing information for this. So I haven't set in a number here like 2 minutes or 5 minutes, and that's because since I have different car types and I have different workers, the times are going to be variable based on a car type. A larger one's going to take longer. So what I'm actually doing here is I'm referencing a spreadsheet called cycle times. I'm using the label value to choose the column, And since this is the first activity, I will use row 2 because I'm using headers in my spreadsheet. So here's the spreadsheet that contains that information. So a lot of users, this is how they'll handle multiple variable cycle times with different product types and different processes. This is absolutely fine to do. However, I would like to show a way to make it a bit more dynamic and flexible by using a special property of our simulation object. So I can go ahead and close this now. And what I'm going to use is I'm going to use something called the index number of our detailing activities here. And an index number, it's a property of any simulation object, and it's going to act sort of as a unique identifier in this case. And we're going to use these index numbers to make multiple references or changes at one time. So in order to show our index numbers, we can go to the View tab and Quick View. And you'll see that this menu opens here on the right-hand side. So we'll take a look at detailing 1, for example, and under the general we'll see its index number. So in this case, the index number is 1. That's absolutely fine. That's what I want it to be. They are sort of randomly generated when you put items on the screen. And I want to make sure that these are matching up. So that's 2 and that's 3 as well. So that's absolutely fine. Of course, you can change these index numbers to whatever you want just by clicking on them. But in this case, I want them to be 1, 2, and 3, as we are going to use that as a sort of mass reference. So now that we've done that, we want to use a visual logic function, and we're going to use that function to calculate our cycle times based on that spreadsheet that I've just shown you. So just a quick overview of a visual logic function. It's a section of visual logic that returns a value. So there are many examples of a function's use. The most common is a mathematical equation. Those of you familiar with Microsoft Excel probably use functions all the time. For example, your sum, your min, and your max in Excel. So I mean, in SIMUL8, functions are a very powerful method of creating tailored calculations. So again, creating your own behavior. And they provide a way for reducing the duplication of visual logic or extra work in your simulation as they get larger and more complex. So again, I've already created a visual logic function, which I can get from my visual logic tab. So for any current users out there, you'll notice that the visual logic editor does look a bit different now for 2014. It's got a nice ribbon and syntax highlighting. So just to highlight what this function is doing, the first command is get current object. And the current object, I've not used an actual object. I've used an object variable, which is a variable that's going to store my activity that is currently calling this function. So when any of my detailing activities call this function, that will be the one that currently gets set in the object activity, the object variable. So once I've done that, once the function has determined what station we're looking at, we want to create a result to actually be used. In this case, it's our cycle time. So I'm going to set our results, and we're going to set that equal to our spreadsheet. That's fine. That's the same as we did before. We're going to use our label. Again, the same as we did before. But instead of having a hard-coded in row, we're actually going to be referencing our index number. So again, what this allows us to do is we can apply this to every single activity in our simulation as long as we look at our index numbers. So again, we've already done that. So I can go up, select my activity. Instead of using a spreadsheet reference, I will use a VL function and double-click on that function to apply it. So that activity is now using that function. And the reason for really doing that is I mean, the key advantages are the maintainability of it. That function exists in one place only. So if I ever need to go change anything in that function, I know exactly where it is. I don't need to worry, maybe it changes everywhere else. It also reduces the risk and errors, perhaps in your spreadsheet references, if you're using kind of hard-coded references. And also it's really expandable and scalable. So I mean, I can create this one activity, and if I have activities that have the same behavior, I can just duplicate it multiple times, and it should be fine. So you see, I have added it here as my cycle time. I've called it the function cycle times, so I can do it for the rest as well. Now, if I decide, I want to add a fourth detailing station. So I've got my spreadsheet, and I can go ahead, type in detailing 4, and then I can fill in some values for that station, and we're just going to keep the 3 car types. So now that I've added that information, or I've maybe imported it from Excel, I can simply duplicate that activity, and it's already got the function there. The only thing, remember, that I need to change is its index. This has an index of 27, so let's change that to 4, and it will now reference the correct cell in my spreadsheet. So I mean, that's a really powerful way to build up and expand your simulations. Now, very quickly, I'd like to just demonstrate, that might seem absolutely great, but, if I had to go in and change the index for, 100 different objects, yeah, I understand, and I completely agree that could be very time-consuming and tedious. So what we can do now is actually, let me just delete these objects. Let's pretend that we want 100 detailing stations. So I've got an index value of 1. I've got my cycle times in there. So let's go to our Homes tab and use the duplication wizard. And 99 times, that's fine. We'll have 100 in total. So you can see I've got all of these here. So the detailing 2 now has an index of 24. That's obviously not right. We want that to have an index of 2. So what we can use is another very powerful visual logic command. If I open this up and show this to you really quick, I'm using a command called loop all objects, and that's all of my selected objects. And in this case, I'm looking at activities. So there's all selected objects and just all objects. There is a difference for this command to work. I do need to actively select any objects that I want to apply this to. And once I have done that, selected my objects and run this code, it will increment a counter from 1, and then it will set that object's index number to the counter. So it will go from 1 to however many you've selected. In this case, it will be 1 to 100. So now that I've shown that off, I'll show you how it works. I can first zoom out so I can see all of my objects, and I'm just going to drag a selection. If I zoom out enough, I can do all of them, but obviously that will be quite large. So you'll see that these are now all actively selected. I can open all of my visual logic from the visual logic tab, find my loop command, right-click, and execute it. And that's it done. It's ran in the background. So now if I click on detailing 2, you will see that the index has now been set to 2. And if I look at any of the other ones, the index will be set, from 1 onwards. So it's a really powerful command that lets you modify the properties of many objects all at once. We will make this model available online, so you'll be able to download it, have a look at the things I talked about, and again, you'll be able to reference that with the recording of the webinar. So I hope that those have demonstrated some powerful features that you'll be able to use going forward in your simulations if you haven't looked at them already. And Matt, I guess before I pass it back to you, I'd like to ask, was there any other questions regarding this?
Yeah, there was one question about all the functionality you've just shown. Is that all available in the current release, or was there anything in 2014?
Yeah, everything that I have shown right now, outside of the ribbon icons and the visual logic editor, the way that it looks. So I mean, the group and the loops and the function, those are all available in 2013 currently.
Okay. There was another question. I think the other question was about versions, and just to clarify, if you have the basic version, then the VL, all of the VL functionality that Glenn just demonstrated isn't available in basic. That's only in our professional version.
Yes, that's correct.
Okay. Good. We've got about 1 minute left in our session today. We really appreciate everyone's attention. We've got a lot of questions, and we're not going to have time to go through all of those questions right now, but we will follow up. We're keeping track of them. We'll follow up with you personally and get your questions answered. But what I would like to do, Jim, if you can come back on, there was one question about collecting data from your simulation. You mentioned that you kind of gather initial data from the simulation. Can you elaborate on that a little bit for one of our attendees?
Well, basically what I do is I'd actually, you were talking about reuse. I have a component called an event logger, and it's very easy for me to add in at different objects a call to log. I think I have up to 8 different things I can log in a single call. And what I do is I basically log this into a spreadsheet. And every time I get 10,000 rows in that spreadsheet, I will actually write that spreadsheet out to my disk with a unique name and start collecting the next 10,000. This lets me collect a large amount of data from a run. So I've got kind of a standard format that I've put together, as I said, in this event logger component. Lets me log out the data, and then it's in the form of a CSV file that I can read into Excel, or I happen to use a package called R for doing my analysis.
All right, Jim, thank you so much. We are out of time. I'm going to take, almost out of time. I'm going to take one more question. There was another question about, if you haven't gotten started yet with simulation, should you start with something complex, or should you start with some simple problems? It really depends on your company. In some companies, management won't pay attention to you unless you solve a complex problem. What you want to watch out for is if you solve 3 or 4 simple problems, management might really not understand the value of what you've done. And so it really depends on what it's going to take to convince your management that this technology has really helped, and then it's worthy of more investment. So I hope that answers that question. We are out of time. Again, we really appreciate everyone attending today. We hope that you found it valuable. We will continue to do these online user forums. If you'd like to participate, please let us know. We will be sending out a follow-up email with all of the links that you need to get to the material we presented today. And if you need to get to us more urgently, please email us at info@simulate.com. Thanks again to all of our presenters, to Jim and to Glenn, and I hope everyone has a great rest of your day. Take care.